Good morning, afternoon, or evening. My name is Josh Chambers, and this is my Lab 5 report that I titled World's Largest Rope Swing. In this presentation, I took this video called Behind the Scenes World's Largest Rope Swing by Devin Graham, and I took the rope swing clip from 117-124, the timestamp, and I tried to determine the speed of the jumper and the tension of the rope. And ideally, I'm imagining that it has no stretch. So after I took this clip from the video, I threw it to Tracker to print out a position versus time graph. Then I went to GlowScript to create a code to try to simulate the same type of graph and also print the values for tension and velocity. And then at the end, I compared both graphs. And yeah, so let's get into it. Hypothetically, the graph should be similar, and approximately the velocity should be 40.39 meters per second, and the tension should be around 3,600 newtons, which I calculated by hand, and I'll show you that later. But as a preview, the GlowScript gave the same shape of a graph, and the velocity is about the same. However, the tension was far off, and the position versus time graph doesn't reach the same numbers as our tracker graph. So let's do a deeper analysis. For our physics principles and sense of surroundings, I said the system was the jumper with 80 kilograms. I wasn't given a mass, so I kind of just assumed that. And the Earth gravity also has a system. And as surroundings, I said the rope and the anchor point. And then we used the conservation of mechanical energy, Newton's second law for circular motion, and the kinematics formula for position updates. So this is Tracker and /Excel. I of course went to Tracker, put in the video the point of mass. It gave me those data points. However, I have to mention there was a time where the man went off screen and I was missing data points, so I had to kind of calculate those numbers and put that into Excel. So I'll let you know everything is probably a little inaccurate, but yeah. That's the graph Excel gave me at the bottom right. And then I also have to mention that the rope length was 45.72 meters that I got from the video as well. Assumptions. The rope is assumed to be non-stretchy and to have zero mass, and also its length remains constant. We're assuming the jumper didn't jump off center and just, we're assuming that any air resistance or friction is negligible. We're assuming that the data I plugged in for the missing data is accurate, and we're assuming the jumper has a mass of around 80 kilograms since we weren't given a mass. And then to the left is how I calculated the tension force and the velocity of the jumper. For GlowScript code, it's pretty lengthy, but mainly it was just me throwing in the formulas, of course, and doing the initial variables. But I will say I did include an anchor position since the rope wasn't just attached to a rock, it was probably attached to the anchor. So I took account of that to help out the geometry a bit. And then I also highlighted how I've calculated the tension force and then put that into the code as well. All right. So then this is two models side by side. You can see that the GlowScript model doesn't go above 0, while the Excel model goes a little below 40. And you go see that the max speed of the jumper was around 40.39, but the tension was 2071, which is about like 1,500 less than what I estimated. So why is this, right? There could have been presence of non-conservative forces, which there probably is, such as air resistance and friction. And also in reality, the rope does have stretch, and which means it's absorbing and releasing energy over time, causing the peak height and maximum speed to be different than the original model. Also, there are most likely data errors on my point from when I calculated the missing values that made the whole thing inaccurate. The jumper most likely started slightly off center, meaning the rope was angled. Probably disrupted the velocity calculation. But most importantly, to find out why tension was so off. Since the video started mid-jump, the simulation never started with the full kinetic energy required. So the GlowScript model somehow calculated a different velocity of 20.4 meters per second, and deleted my input velocity, which led to a much lower tension of 2195 newtons. But still, we were able to print a graph for the position versus time, and still got a velocity and tension calculated. So this concludes my presentation. Thank you so much for watching. Have a good day.